Hello everyone and welcome back to the series of digital logic design, and today we will study Boolean functions. A Boolean function is a Boolean algebraic expression which consists of binary variable, the constant 0 and 1, and logical operation symbols. Or we can say that a Boolean function expresses the logical relation between the binary variable and is evaluated by determining binary value of expression for all possible combination of the variables. Like in normal arithmetic, we have a functions which represents a working of a system. Similarly, the working of a digital system can be represented through a Boolean function, and a Boolean function can have a value of 1 or 0 as binary variables have values 1 or 0. We have studied that Boolean algebra deals with binary variables, logical operations, and identity elements. Now consider the given example where function f1 is equal to x plus y prime z. Now we know that the output of a function can either be 1 or 0. Now we will analyze the output of function f1 by inspecting. If you look at f1, this is sum of two terms. First one is x and second one is y prime dot z. And the function f1 will have a value of 1 when either x is 1 or y prime dot z equals 1. And for all other cases, its output will be 0. Or we can say that y prime dot z will have a value of 1 if y is equal to 0, so its complement will be 1, and variable z will have a value of 1. Now a truth table can be computed for a Boolean function which represents output of the function for all the possible combination. The number of rows in the truth table depends on number of variables and is equal to 2 power n, where n is the number of variables in a function. The binary combinations for all the variables in a truth table are obtained from the binary numbers by counting from 0 to 2 power n minus 1. Now for the given function f1, we have a truth table. The function has three variables x, y and z, where in the truth table we have 8 possible binary combinations starting from zeros and end on the 7. The column f1 can have a value of 0 or 1. The table shows that the function is 1 when either x is equal to 1 or y prime dot z equals to 1, or we can say that y is equal to 0 and z is equal to 1. And function f1 is 0 for all other cases. A Boolean function from an algebraic expression can be transformed into a circuit diagram which is composed of logical gates connected in a particular structure, and the structure is defined from the equation. While during this, the operator precedence is being followed. The logical circuit diagram is also known as schematic, where it expresses the relationship between output of the circuit and its input. While making the logical circuit diagram, the variable of the function are taken as input and the function variable is taken as the output of the circuit. The schematic of the function f1 is shown in the figure. Starting with variable x, y and z, these variables act as an input to the circuit, and the function variable f1 will act as the output of the circuit. Then we place an inverter to generate y complement, and then we use AND gate for the term y prime dot z. In the end, we have an OR gate to generate sum of x and y prime dot z. And finally, we have a schematic of the function f1. Thanks for watching the video and stay connected for more interesting videos.